Okay, class. Now, I know we worked on problem number 1, so let's look at problem number 2, which is 7/8 plus 3/9. When we want to find lowest common denominator, we want to find multiples of 8 and 9 that are shared. What I mean by that, class, is, let me get a blank page going here. So, 8 and 9. If I count by 8, keep going, keep going, let me see, 40, 48, 56, 64, 72, 80. I'm going to get a few of them going, okay? Now let me use red for 9. 9, 18, 27, 36, 45, 54, 63, 72, 81, and I'll go one more to 90. To 90, sorry, 90. There we go. What I want to do is find the first number that they share. Now I counted by 8s, which would be 8 times 1 times 2 times 3 and so on. Now if I look through the first 6, there's nothing that they share. But if I continue looking, there is one that stands out, 72. Now, what do I multiply 8 times to get to 72? Well, this one just happens to be the opposite number that I'm working with, which is 9. So 7/8 times, now my denominator is going to be multiplied times 9 because I want to have the same denominator for both fractions. But I have to multiply my numerator by the same thing, plus 3/9. Now, whoops, get rid of that, sorry about that. 3/9. I have to multiply that times 8, but also I have to make sure it's 8 over 8. Okay? Now, if I multiply across right here, I get 63 over 72. If I multiply across right here, I get 24 over 72. Now, again, I want you to remember, right here you're adding across, right here you're not. What happens is your denominator stays the same, 72. 63 plus 24, if I add those together, I get 87. Now let me use another page to address another issue, 87 over 72. This is what's called an improper fraction. Now, it can't stay an improper fraction. It has to become what's called a mixed number. To do that, I divide 72 into 87, and I see that it goes in there one time. I subtract, and whatever my remainder is will be my numerator. Okay? Now, however many times it went in, that's my whole number that goes up front. My remainder, which is 15, becomes my numerator. And finally, my original denominator stays the same. Whoops, it wasn't 15, sorry class. 72. And I can look to see if it can still be simplified. Now right here, I know that 15 can be divided by 3 and 5, but let's try 3 on both of these. What do I get? Well, I still move my whole number over. 15 divided by 3 is 5. 72 divided by 3 is actually 24, and I can double check by multiplying. That's 6 plus 1, yep. My final answer would be 1 and 5/24. So let me clear all this up. 1 and 5/24. So what we're actually doing, class, is we're looking to find multiples that the denominators share. You could use the method I mentioned before where I take the opposite numbers denominator and multiply it times the opposite fraction. For example, 1/9, the opposite or the other fraction is 4/7. So its denominator, 7, would be multiplied times 1/9. And when it's multiplied, I mean 7 over 7. Okay, so I'm adding 4/7, and I'm going to take that 9 and multiply the numerator and denominator by it. What I end up getting is 7 over 63 plus, multiply across, 36 over 63. If I add now across, that's 43 over 63. So class, we want to find numbers that work. This method will always give you a denominator that works. Sometimes you don't have to do that. If we look at number 6 right here, I don't need to multiply 2/3 times 9 over 9. This is where my times tables comes in, because I can save myself a lot of trouble by looking at it and saying, well, 3, if I count 3, 6, 9, well, 3 and 9, well, 9 is a multiple of 3, so I don't need to do anything to 3/9. So minus 3/9. I just need to take 2/3, turn my denominator into 9 by multiplying times 3, do the same thing to the numerator, and I get 6/9 minus 3/9. My denominator stays the same, 9, that's done. So what's 6 minus 3? 3/9. Can I simplify? Yeah. Let's divide by 3, divide by 3. That equals 1/3. So class, again, look at what you're working with. If you don't need to use that method, such as, here, let me create a new problem for you. 3/5 plus 2/7. Oh, then I have 3/5 times 7 over 7. This will always work for you. But when I ask you to simplify it, that's where the difficulty might come in. And it might cause a little more work to happen, but you will be put in the proper format. You will end up with numbers that work. For example, right here, I will end up with, let's see, let me duplicate all. Sorry, class, I write too big sometimes. Get rid of all this stuff right here. Sorry about that. So, if you look over here, I end up with 21 over 35 plus 10 over 35. Again, multiplying across, 5 times 7 is the same as 7 times 5. Combine them, you get 31 over 35. And you're done. So, always look to have the same denominators. If you don't know your multiples, if you have a hard time with times tables, use the method that I just showed you, where you take the opposite fraction's denominator, and multiply the other fraction times it. And in this case right here, I took 7, multiplied it times the first fraction, and I took 5 and multiplied it times this fraction.